A star is dying. Right now, somewhere in our galaxy, a massive star has run out of fuel and is about to experience the most violent, most powerful, most luminous event in the known universe. For a brief moment, a single dying star will outshine its entire galaxy, billions of stars combined. It will release more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. This is a supernova. And understanding how it happens will change the way you think about every atom in your body. Let us start at the beginning. Stars are born when massive clouds of hydrogen gas collapse under their own gravity. As the gas compresses, the core heats up until it reaches about 15 million degrees, at which point hydrogen atoms begin fusing into helium. This nuclear fusion releases enormous energy, and that energy creates an outward pressure that perfectly balances the inward pull of gravity. The star reaches equilibrium. It can burn steadily for millions or billions of years, depending on its mass. Our sun has been doing this for about 4.6 billion years, and has roughly another 5 billion to go. But massive stars, those with more than about 8 times the mass of the sun, live fast and die young. A star 20 times the sun's mass might burn through its hydrogen fuel in just 10 million years, a thousandth of the sun's lifetime. And when the hydrogen runs out, the star does not simply fade away. It begins a desperate series of last-resort nuclear reactions that will ultimately destroy it. When the hydrogen in the core is exhausted, the core contracts and heats up further until it is hot enough to fuse helium into carbon. When the helium runs out, it fuses carbon into neon, then neon into oxygen, then oxygen into silicon. Each new fuel source burns faster and faster. Hydrogen fusion lasted millions of years. Helium burning lasts hundreds of thousands. Carbon burning lasts a few hundred years. Silicon, the final fuel, burns through in a single day. Just one day. And at the end of silicon burning, the core has been converted into iron. And iron is where the story ends. Every element lighter than iron releases energy when it fuses. Iron is different. Fusing iron does not release energy. It absorbs it. There is no more fuel. The fusion reactions that held up the star for millions of years stop in an instant. And in that moment, gravity wins. The iron core, roughly the size of the Earth but containing more mass than the sun, collapses at about a quarter of the speed of light. In less than 1 second, the core shrinks from the size of Earth to a ball roughly 10 miles across. The density becomes so extreme that protons and electrons are crushed together to form neutrons. The collapsing core literally becomes a single, enormous atomic nucleus. This is the birth of a neutron star. The collapse is so sudden, so violent, that the outer layers of the star, still falling inward at tremendous speed, slam into the newly formed neutron star core and bounce. That bounce sends a shock wave outward through the star with absolutely inconceivable energy. The shock wave, augmented by a flood of neutrinos escaping the core that deposit additional energy into the falling material, rips the star apart from the inside out. This is the supernova explosion. And the numbers are almost too large to comprehend. The energy released is approximately 10 to the 46 joules. That is more energy than the sun will emit in its entire lifetime, released in a matter of seconds. For weeks, a single supernova can outshine an entire galaxy of 200 billion stars. It is so bright that supernovae in distant galaxies are visible from Earth with the naked eye. The supernova observed by Chinese astronomers in 1054 CE was visible during the daytime for 23 days. The remnant of that explosion is the Crab Nebula, a spectacular cloud of gas still expanding outward nearly 1,000 years later with a rapidly spinning neutron star at its center. But here is the part that should give you chills. Supernovae do not just destroy, they create. During the extreme temperatures and pressures of the explosion, Nuclear reactions produce every element heavier than iron. Gold, silver, platinum, uranium, iodine, copper, all of these elements can only be formed in the furnace of a dying star. Every gold atom in every wedding ring, every copper wire in every building, every iodine molecule in your thyroid gland was forged in a supernova explosion billions of years ago, then scattered across space, eventually condensing into the cloud of gas and dust that became our solar system. You are, quite literally, made of dead stars. The calcium in your bones, the iron in your blood, the oxygen you are breathing right now, all of it was cooked inside a star that lived and died before our sun was even born. You are not just looking at the universe. You are the universe looking at itself, assembled from the ashes of ancient stellar explosions. And supernovae do one more extraordinary thing. The shock wave from the explosion compresses nearby clouds of interstellar gas, triggering them to collapse and form new stars. Stars make the elements that make planets, that make life. And when those stars die, their deaths trigger the birth of new stars. It is a cycle of stellar death and rebirth that has been running for over 13 billion years. Every generation of stars enriches the universe with heavier elements, making each successive generation more chemically complex, until finally, around a small yellow star in an unremarkable galaxy, enough heavy elements accumulated to form a rocky planet with liquid water and the right chemistry for life to emerge. That planet is Earth. And you are here because stars died. The most destructive events in the universe are also the most creative. Without supernovae, the universe would contain nothing but hydrogen and helium, two boring gases floating in an eternal void. No planets, no water, no carbon, no life. The fact that you exist is a direct consequence of stellar violence on an incomprehensible scale. If that does not make you feel simultaneously tiny and magnificent, nothing will. Subscribe for more cosmic perspective. The universe has plenty